Robots in space.
Hello everyone, I'm Mike DiVerde. I'm an aerospace engineer. Today I'm wearing my SpaceX Dragon shirt. I worked on the design for Dragon's second cargo resupply mission, CRS-2, which launched on March 1st, 2013. That mission took heavy thermal radiator grapple fixtures up to the International Space Station. Almost 20 years prior to my engineering efforts at SpaceX, I was a primary structure lead engineer for the Space Station Truss when I worked at McDonnell Douglas Space Systems in Huntington Beach, California. So this photo you see captures both of these space projects that I worked on, as the robot arm on the space station pulls the grapple fixtures out of the trunk of the SpaceX Dragon. On today's episode of Robots in Space, I'll discuss missions by three different spacecraft orbiting Mars: Mars Reconnaissance Orbiter, MRO, Mars Global Surveyor, MGS, and Mars Express Orbiter. We'll watch an overflight of an area of particular interest, Noctis Labyrinthus. Then I'll discuss findings from 4 different research papers. The overview for today's episode is like this. Water in fairly large quantities is being detected on Mars. Not only did water take part in creating Noctis Labyrinthus, this maze of irregular canyons could also be a likely place to search for native Martian life forms. However, the main point is that Noctis Labyrinthus would be one of the premium Martian equatorial locations for landing, exploring, and colonizing this planet someday. Mars Reconnaissance Orbiter was launched on August 12, 2005, and it reached Mars on March 10, 2006. In November 2006, after 6 months of aerobraking, it entered its final nearly circular orbit at approximately 155 to 196 miles, and it began its primary science phase. It is still operational on Sol 6676. Mission objectives include observing the climate of Mars, investigating geologic forces, and relaying data from surface missions back to Earth. MRO carries 3 cameras, 2 spectrometers, and a subsurface radar. Data from MRO has been used to choose landing sites for landers, to discover pure water ice in craters, and to determine that water once flowed on the surface of Mars. The shallow radar, SHARAD, sounder experiment on board MRO is designed to probe the internal structure of the Martian polar ice caps. It also gathers planet-wide information about underground layers of regolith, rock, and ice that might be accessible from the surface. SHARAD emits HF, high frequency, radio waves from the 2 rod antennas, which resolves individual layers as thin as 20 feet thick to a maximum depth of 2 miles. SHARAD is designed to complement the Mars Express Marsis instrument, which has coarser resolution but penetrates to a much greater depth. Both SHARAD and Marsis were made by the Italian Space Agency. HiRISE stands for the High Resolution Imaging Science Experiment, one of 6 science experiments. This instrument is designed to produce the most detailed pictures of Mars ever taken from orbit, revealing surface details as small as 3 feet across. The Compact Reconnaissance Imaging Spectrometer for Mars instrument, PRISM, is a visible and near-infrared spectrometer that is used to produce detailed maps of the surface mineralogy of Mars. PRISM is being used to identify minerals and chemicals indicative of the past or present existence of water on the surface of Mars. These materials include iron oxides, phyllosilicates, and carbonates, which have characteristic patterns in their visible infrared energy. The PRISM instrument was shut down on April 3rd, 2023. Mars Global Surveyor, MGS, was an American robotic space probe developed by NASA's Jet Propulsion Laboratory, launched on November 7th, 1996, and its primary mapping phase began on April 1st, 1999. MGS was a global mapping mission that examined the entire planet from the ionosphere down through the atmosphere to the surface. Mars Global Surveyor performed atmospheric monitoring for sister orbiters during aerobraking and helped Mars rovers and lander missions by identifying potential landing sites and relaying surface telemetry. On November 2nd, 2006, the spacecraft failed to respond to messages and commands. Attempt to recontact the spacecraft and resolve the problem failed, and NASA officially ended the mission on January 2007. MOC, Mars Orbiter Camera Science Investigation, used 3 instruments. A narrow-angle camera that obtained grayscale high-resolution images, and both a red wide-angle camera and a blue wide-angle camera for context and daily global imaging. MOC operated in Mars orbit between September 1997 and November 2006. And now, my favorite space science instrument of all time, the Mars Orbiter Laser Altimeter, MOLA, which was designed to determine Mars global topography. Look at that clear and obvious depiction of the high points and low points on Mars. Beautiful. Credit to Maria Zuber and David Smith for their laser altimeter research. This is the usual portrayal of the data, which presents a clear view of the entire planet from east to west and north to south. It operated as an altimeter until a portion of the laser reached end of life in June 2001. The instrument then functioned as a radiometer until October 2006. But look at this version. with the data on the two hemispheres. Wow! As it is in three-dimensional space. Now, here is the area on Mars of prime interest, Noctis Labyrinthus. Translation is night labyrinth or night maze. To the west, you can see one of the Tharsis volcanoes, and to the east, the colossal Valles Marineris Canyon, largest ever in our solar system. Valles Marineris translates as Mariner Valleys, and this was named for the Mariner 9 spacecraft, which discovered it in 1972. This map provides critical data if you want to consider water flow in Mars past. The height difference between the top of a Tharsis volcano all the way down to the bottom of Valles Marineris is about 12 miles, which is about 20 kilometers, which is about 63,000 feet. See, you can imagine water flowing down slope from glaciers, paleo lakes, and groundwater as the Tharsis volcanoes began to rise in the west. The Mars Express Orbiter has been successfully performing scientific measurements since early 2004, namely high-resolution imaging and mineralogical mapping of the surface, radar sounding of the subsurface structure down to the permafrost, precise determination of the atmospheric circulation and composition, and study of the interaction of the atmosphere with the interplanetary medium. Arriving at Mars in 2003, 20 years, 11 months, and 24 days ago, which is about 7,525 sols. It is the second longest surviving, continually active spacecraft in orbit around a planet other than Earth, behind only NASA's still active 2001 Mars Odyssey. The Marsis instrument is of prime importance. On May 4th, 2005, Mars Express deployed the first of its two 20-meter-long radar booms for its Marsis experiment, which stands for Mars Advanced Radar for Subsurface and Ionosphere Sounding. Both 20-meter booms were needed to create a 40-meter-long dipole antenna for Marsis to work. A less crucial 7-meter-long monopole antenna was deployed earlier. Nominal science observations began during July 2005. For reference, 40 meters is 130 feet, a very long and thin rod antenna. The radar altimeter was used to assess the composition of the subsurface to search for frozen water. Here is an image of subsurface water that was detected by Marsis near the south pole of Mars. The Marsis instrument was used to discover a large amount of subglacial liquid water on Mars. Quoting from the research paper entitled Radar Evidence of Subglacial Liquid Water on Mars, we surveyed the Planum Austral region using the Marsis instrument, Mars Advanced Radar for Subsurface and Ionosphere Sounding, a low-frequency radar on the Mars Express spacecraft. Radar profiles collected between May 2012 and December 2015 contain evidence of liquid water trapped below the ice of the South Polar layered deposits. Anonymously bright subsurface reflections are evident within a well-defined 20-kilometer wide zone centered at 193 degrees east, 81 degrees south, which is surrounded by a much less reflective area. Quantitative analysis of the radar signals shows that this bright feature has high relative dielectric permittivity, greater than 15, matching that of water-bearing materials. Here's the point. We interpret this feature as a stable body of liquid water on Mars. Now we will watch the excellent video from the Mars Express orbiter. Enjoy. So why is anyone interested in Noctis Labyrinthus? For that, we need to listen to Pascal Lee, a fabulous researcher at NASA Ames and the Mars Institute. Let's look at his recent paper entitled A Relic Glacier near Mars equator. Evidence for recent glaciation and volcanism in eastern Noctis Labyrinthus. The paper was written by Pascal Lee et al. 2023. Summary. A light tone deposit in eastern Noctis Labyrinthus presents distinctive morphologic characteristics of a glacier. Although the glacier is likely relic, the preservation of fine-scale glacial features opens up the possibility that water ice might still be preserved beneath the light-toned deposit material. Recent equatorial glaciation, volcanism, and volcano ice interactions on Mars are implied. Noctis Landing is attractive to explore as it enables access towards the east to Valles Marineris and its extensive record of Martian geologic history to search for signs of past life, and towards the west to Noctis Labyrinthus, the Tharsis volcanoes beyond, and their many lava caves to search for extant life. Hydrated minerals are present in Noctis Landing in a wide variety of forms among the many light-toned deposits in the area. Water ice fog has also been interpreted as a common occurrence in Valles Marineris and Noctis Labyrinthus. However, there is as yet no evidence in this region of water ice in surface or near-surface materials in the current epoch. This is not surprising, as water ice would not be thermodynamically stable if exposed directly to current annual atmospheric pressure and temperature conditions in Mars equatorial regions. Two possible current states are hypothesized. One, all the water ice is gone, but the light-toned deposit has formed a veneer, preserving the glacier's morphology in relic form down to its finer details, such as crevasse fields. Or two, some water ice is still there, but it is blanketed by light-toned deposit material, which insulates it thermally and diffusively, as with ancient ice islands in Altiplano Salars. Pascal Lee et al. Wrote a short paper describing the advantages of using Noctis Labyrinthus as a landing site, entitled Noctis Landing, a proposed landing site and exploration zone for human missions to the surface of Mars. It was written by Pascal Lee et al. In 2015. So this predates the paper we were just talking about. Observe his map and consider his highlights. The relic glacier is not noted on this map, which predated the relic glacier paper, as I just said. However, I have added a large blue arrow that points to where I believe Pascal Lee identified the relic glacier of his other paper. The solid red circle marks the distance of 100-kilometer radial range from the landing site, which is the black dot at the center. White dotted lines represent potential paths for pressurized rover traverses. White solid circles mark locations offering potential resources such as water ice, hydrated minerals, iron, and sulfur-bearing minerals. Now, quoting from his research paper, the proposed site also contains regions of interest that offer the following resource characteristics. 1. Access to raw material that exhibits the potential to A. Be used as feedstock for water generating in situ resource utilization processes, and B. Yield significant quantities, like more than 100 megatons of water. C. The raw material is likely in the form of hydrated minerals and possibly an ice and regolith mix. The top of the raw material deposit is at the surface. Makes it easy to grab. Number 2, access to a region where infrastructure can be emplaced or constructed. This region is less than 5 kilometers from the landing site and contains flat, stable terrain. The region exhibits evidence for an abundant source of loose regolith. Several deep pits in the area, combined with the availability of sand, suggest that some natural terrain features can be adapted for construction purposes. 3. Access to raw material that exhibits the potential to be used as metal feedstock for in situ resource utilization and construction purposes. Iron and sulfur-rich mineral surface deposits have been identified in CRISM data in many locations in this area. And here's just my aside. I think that there's an awful lot of iron and sulfur all over Mars, frankly. Number 4, Noctis Landing is the lowest altitude location on Mars that straddles both the Tharsis region with above average geothermal gradients and Valles Marineris with minimal crustal thickness from the valley floor to a subsurface liquid water table. So you got heat energy and relatively easy access to a water table. And 5, Noctis Landing has the potential for being an ideal site for eventual deep drilling on Mars to access deep subsurface liquid water and potentially encountering extant life. Everybody's looking for those Martian microbes. We've now arrived at the primary research paper, the final of 4. The main themes of the research paper, entitled Groundwater Flow Induced Collapse and Flooding in Noctis Labyrinthus, Mars. So here's kind of the first theme is groundwater flow and geological processes on Mars. The research paper discusses the role of groundwater flow in the formation and collapse of geologic structures in Noctis Labyrinthus. It highlights how groundwater flow from the Tharsis volcanic rise contributed to the evacuation of large basins and chasmata in the region. Chasmata is just a fancy way of saying multiple canyons, right? Chasm, chasmata. So the second main theme is catastrophic floods and aquifer systems. The research paper explores the hypothesis that catastrophic floods, driven by the evacuation of aquifers and ancient lakes, played a significant role in shaping the Martian landscape, particularly the circumcrisi outflow channels. The identification of hydrated minerals such as opal, gypsum, and sulfates within the basins of Noctis Labyrinthus points to past aqueous activity and the presence of water-rich environments. The 23,000-foot elevation difference between Cirria Planum and the floor of Tithonium Chasma suggests a significant hydrostatic pressure that would have been sufficient to drive large-scale groundwater flow and discharge. So now I'll quote from the research paper: interpretive synthesis, formation and inundation of enclosed basins in Noctis Labyrinthus. We propose that the tectonically aligned troughs, pits and enclosed basins of central and eastern Noctis Labyrinthus likely developed as a consequence of surface collapse over conduits generated by fault-controlled groundwater flows. So I'll have you look at figures 1A and 1B now. Our findings indicate that these flows sourced from an aquifer system in northeast Syria Planum and discharged into the floors of ancestral basins produced during the early rift stages of western Valles Marineris. So now you want to look at figures 13A panel 1 and 13B. Theme 3 is geological evidence and remote sensing data. The study utilizes remote sensing images and topographic data from Mars Reconnaissance Orbiter and Mars Global Surveyor to map and analyze the morphometric and morphologic characteristics of Noctis Labyrinthus. Quoting from the research paper, we have also identified numerous decameter scale landforms within this basin which, based on assemblage, comparative geomorphology, and the proposed paleolacustrine geologic context, we interpret to have likely developed in periglacial settings. These landforms include 1. Domes that locally exhibit summit pits. So I'm going to point out the figures to you. So look at figure 6A for that, okay, for the summit pits, domes with summit pits, which we interpret as pingos. So look at figure 6B now. And by the way, a pingo, I had to look up, I've never heard of it before. It's a hill or a mountain that's got ice at the core of it. And so a lot of these things that we're going to describe here are things that you see on Earth in Arctic regions where the thaw-freeze cycle creates some unusual landforms. So anyway, pingos, right? That's in 6B. Continuing now. Or mud volcanoes. So that's shown in figure 6C. Number 2 is shallow irregular depressions. That's figure 6D, which we interpret as produced by thermokarst melting. That's figure 6E and F. 3, patterned ground. So look at figure 6G now, which we interpret as produced by expansion-contraction episodes associated with ice freeze, thaw, condensation, sublimation cycles. Now you're going to look at figure 6H, or by sediment desiccation, figure 6I. As observed in terrestrial polygons developed in ice-rich permafrost regions and salt playa lake environments, the documented Martian polygons range from a few to about 20 meters in diameter. Fourth theme, hydrated mineral deposits and lacustrine features. The document identifies the presence of hydrated mineral deposits and features indicative of ancient lakes and periglacial processes, suggesting a history of aqueous activity in the region. Quoting from the research paper, the presence of widespread hydrated salt deposits within the central Noctis Labyrinthus basin is in agreement with a conduit origin linked to the dissolution of regional upper crystal salt deposits, aided perhaps by suffusion resulting from groundwater flow along regional faults extending across buried, unconsolidated sedimentary deposits. We interpret the ridges that mark the northern and southern margins of basin. Now you're going to look at figures 3D and 3E as possible lacustrine paleoshorelines that were likely produced as sediments that were pushed outwards during expansion freezing cycles of the lake's surface. And now you want to look at figure 3F. Fifth theme is the astrobiological potential. The findings highlight the potential of Noctis Labyrinthus as a prime region for astrobiological exploration due to its long-lived integration of subsurface and surface hydrologic environments, which could have been habitable. Quoting from the research paper now, the long-lived integration of subsurface and surface hydrologic environments, perhaps enriched by nutrients, by hydrothermal processes, could have favored the development of potentially habitable environments. Therefore, this region of Mars comprises a prime candidate for astrobiological exploration. These themes collectively contribute to an understanding the geologic history and potential habitability of Mars, particularly in the Noctis Labyrinthus region. Here is a very clear diagram of what the researchers are proposing for the water flows on Mars that created much of Noctis Labyrinthus. So if you look at figure 13, panel A, sketches illustrating the proposed model for collapse and inundation in central and eastern Noctis Labyrinthus. One, this is you look at the left-hand side, the figure at the top there, groundwater flow dominated by a radial trend from Serioplanum to ancestral basins in western Valles Marineris generate extensive systems of nested conduits along pre-existing faults. So then you go to the second sketch down. Collapse over excavated conduits forms enclosed basins in central and eastern Noctis Labyrinthus. Third sketch down is the floors of the basins accumulate widespread lacustrine sediments and lavas. And then the fourth, the bottom sketch, surface erosion associated with eastward large-scale mass flow discharges results in the merging of eastern Noctis Labyrinthus basins and Tithonium chasma. Tithonium chasma accumulates large volumes of sedimentary deposits, including possible lacustrine materials. Now, if you look at the right there, panel B, the very interesting diagram there. MOLA, remember that's the laser altimeter, MOLA shaded relief map showing the proposed drainage paths of an aquifer in Serioplanum, and then the red shading and blue arrows show the inferred flow directions. The aquifer's approximate location is marked by the blue shading. So here is my summary of the researchers' hypothesis for the creation of Noctis Labyrinthus. Number one, ancient Mars had huge lakes and underground groundwater reservoirs. Then the Tharsis volcanoes began to rise, and the elevation of the surface created a downslope for water to flow. And the magma that supplied the Tharsis volcanoes provided heat to melt surface glaciers. So 2 is there's a potential that magma chambers that were previously in the Noctis Labyrinthus zone emptied, creating collapsing colossal caverns. So they got squeezed out. So as the volcanoes rise in the west and heat up the above ground glaciers, the ground begins to collapse under Noctis Labyrinthus. Another potential mechanism is that the surge of water flows underground through the salt-rich deposits, dissolving them. Either separately or in concert, the magma chambers or the salt deposits create caverns, and then the previously flat surface collapses into what we now see as Noctis Labyrinthus. Omni. Futurists.